Hello everyone, I'm Bradley Sward and this is my Day 17 Part 2 solution to Advent of Code 2024. The problem is known as Chronospatial Computer. I'm solving this in Python, and this is probably about the coolest problem, Advent of Code, at least my opinion. This was a really cool problem for me anyway. About 4 days from now, my C++ solution will have an answer, even though it's running way faster than Python ever could. But it's still going to take about 4 days of computing to get to where it was from an algorithm I had designed previously. It will get an answer. It's just now that I know what the answer is, I can pretty much estimate I'm about 4 or 5 days away from it computing by just following the old rules here. So part one of the problem, for those of you who are kind of remembering here, is that you're creating your own virtual machine, your own virtual CPU that has an instruction set and different operands and different operations, and the computer just does what it does and you get your answer. And I thought it was weird the first time ever, I believe I've ever seen something other than just numbers in my puzzle answer, which threw me off originally by about 10 minutes because I didn't realize. I just thought they wanted me to concatenate the numbers together. But anyway, even though it very clearly shows this, my brain just went, that's not what they want. But anyway, so for part two, now that we have a working computer, and here's where the really cool part is. If I start and I put some number, just some number into register A, and 0 into B and 0 into C, and then I give it the programming, the output to the program will be the program itself. So like in this case, if you put 117,440 into register A with 0B and 0C and run it against this program with the on that CPU, you would get you will get the right answer. Whatever you know the you'll get the program. So anyway, so here it is in Python. Here is my solution. Let me find it here. So what in the heck am I doing? So this is still stuff from part one. But now for part two, this is where the fun begins. You can see there's actually, like everything else, right? There's not a lot that you add to make this thing work, but what you add is the very important part. So as it turns out, if you run your programs, let me see if I can find, here we go. If you run your programs, the goal is to get the output of all the digits, right? So like in my case, there's 16 digits. Here's my data set. Here's my problem space. And so there's 16 digits to this thing, and what happens is, like you saw, if I brute force this, it's going to take, and this is the day approach, other people years, right? And so what I'm trying to do, like after having the epiphany, was just like, well, okay, if I need to get all 16 of these digits in a row, well, I got to start from digit 1, right? And so my goal was to figure out all the index values, or all the values I could put into register A that could get me the first digit. And then I looked at that pattern and I found that this happens. If you start from 4 and you add 8, then add 8, then add 8, and add 4, and when you get to here, you come back around. If you follow that pattern, every one of these things will always be a 2. It will always get me the first digit of a 2. And then my code, also showed me, like, while trying to go through and like, let's find the subset, or basically when does it repeat. Again, the tricky part was I did do this all by hand, at least for the first 3 steps, and then I'm like, I got to do this 13 times more, and I'm like, I did not want to do this by hand, so I'm like, let's figure out how to get the computer to do it. So I have, then from this case here, this will get me the first digit, and then I start over with this understanding. Instead of just starting from 1 and 2 and 3 and 4, well, now I'm starting from 4 and 12 and 20 and 28 and 32, all that, whatever, and I'm saying from now that list of numbers, get me all the values that have the first 2 digits. And so starting at 703 and then working our way, whatever reason, there's always an offset, which is fine. So starting from this number and working through this list, you will get all the values that have digit 2. And again, now, like getting this thing to work for all 16 was the fun part. But you can see that, now for digit 3, whatever, like, it's not saying that these are answers, obviously, but these are only the potential values that could be correct And we're reducing the search set. What did I have it by? By 14, then 100, then 1,000. You know, like basically kind of multiplying by somewhere between 12 and 14 every time, like speeding up the search by 12, then another 12, then another 12, and it's so you're thinking like 12 to the 16th power of how much faster this algorithm is than the other ways of doing things. What is 12 to the 16th power? Yeah, that's a big number, right? So, but anyway, so I don't know if that's true or not anyway, but beside the point. But all you do then is if you continue your way down and you're like, well, for 3 digits, these could be the only answers. And for 4 digits, this could only be. And if you keep working your way through of that there, as you keep working and as you keep making this, some of these things are bigger and some of these things are smaller, just the way it worked out. I don't know why. Oh, I guess it printed this out twice for some reason here. I don't know what happened. But then eventually, yeah, whatever, it's all good. But eventually, when you work down here, you finally get to the point where you find the actual solution. It didn't have to go all the way up to 16. While it was trying to find the 1,000th digit of the 12, or the 1,000th value that would work for 12 digits, it found the actual answer. And so there is my answer. I don't need to continue on with anything more here. And there is my solution. So let's go back to the code so you guys can see what I have done here. So again, like this is all the baseline stuff. The key here was basically I did this 16 times over, or the length of my program, 16 times over. Every time I got to the print operation, I made sure I added to this new list of items, and I made sure that when it gets to 1 or 2 or 3 sizes, that the sizes are the same. Otherwise, I break out and continue on. And so when I get to the end here and I go, okay, it's okay that the numbers match up, or everything matches up, and I add it to the list. I said 1,000. I didn't know how many. I didn't know I could use only about 400 or something. So that would speed up my program as well. Get it down to maybe about 5 minutes or 4 even. I don't know. I don't really want to know anymore. But as much as this problem has been amazing. So but there you go. Here now at the end, you're like, well, what is that length? And then you set it up for the next round. You're like, okay, with this starting number and this list of numbers, get me the next generation. Get me the next, and then the 16th generation, or in our case, the 12th, is the one we care about. So that, I almost feel bad solving it, because that was so much fun. What does day 18 have in store? Who the heck knows? But I'm moving on. So have a great day, everybody. Thanks for watching. If you know a better way to do this, I would love to hear it, but definitely have one here. Have a good one, everybody. Take care. Talk to you later.